Greetings, everyone, and in this segment, we will talk about the future of 3D animation in AnyLogic models. So right now, current 3D animation does not provide much variety and detalization for object presentation. It also lacks additional effects like shadows, textures, and reflections. So one possible option for development of model animation is utilizing external platforms and engines to create the so-called photorealistic animation. There is a number of such platforms that allow for integration of their 3D graphics toolkit, and after careful consideration, we decided to focus our attention on NVIDIA Omniverse. So according to NVIDIA, Omniverse is a platform of APIs, SDKs, and services that enable developers to easily integrate OpenUSD and RTX technologies into existing software tools and simulation workflows. And one of the cool features of Omniverse is what is called a live session, which allows several users to connect to a single 3D scene, view it, and edit it. We utilize this feature to connect to the scene from AnyLogic and apply changes to it right from the AnyLogic model. So in a little demo, we will try to showcase some features provided by integration with NVIDIA Omniverse that will soon be available in AnyLogic. And we will show a pre-recorded video, since that will allow us to show a full cycle of creating the scene and then upgrading it. And we'll start with creating the 3D scene for a model, and we'll take a distribution center as an example model. So one of the new features for AnyLogic is that now for the existing model, AnyLogic can automatically create a basic 3D scene. To do that, in the open model, we use the render command in the model menu. And in the open dialog, all we need to do is select the top level agent and specify the path to the resulting file. We can get that path from the Omniverse itself. So we create a folder here. We copy its path and add a file name of our choosing. Also notice two options here, which are export 3D objects to separate files and open the scene on render finish. So now the model rendering is happening, and all 3D objects, except top-level agent objects, are being rendered. And during this process, for each object, a USD file is created that will represent the object on the scene. And this is a very basic step that you can take to create a layout for your 3D scene. So this process will render the scene, and from that scene, you can even further improve your animation. So the rendering is finished, and let's see the result in the Omniverse. Yeah, even now we can already see our rendered 3D objects with shadows, transparent objects, reflections, and so on. We can see shadows on the rack storages. We can see transparent walls and detailed objects. We can pan around the scene, zoom in and out. And we see our basic AnyLogic trees were rendered into Omniverse trees, say. Okay. Now, to connect the model to NVIDIA Omniverse, we need to add a new object, which is called Omniverse Connector from the presentation palette. It should be placed in one of model's agents. Right now, we allow only one connector per model. So connector's main property is the path to the 3D scene. We'll use, of course, the scene that we just created, copy its path and paste it to Omniverse Connector. Can uncheck the mark so that the scene will not be opened on model start, since we have it already open. So now let's run the model and compare the animations between Omniverse and AnyLogic. We connect to the live session. So now Omniverse application starts receiving data from the AnyLogic model. Okay, let's run the model and see the result. On the right, AnyLogic boxes are appearing on rack storages and changes are being transferred to Omniverse. And we can see, as I said before, the animation is much more detailed and vivid, with shadows and reflections being added. And the trucks are more detailed, the rack storages are, and right now we can see the palettes on rack storages with default boxes. We will also show later in this video how to improve the look and variety of those boxes. And of course, the AGVs or transporters are much more detailed. And we basically didn't do anything to achieve that state. So no code was written, no assets were created, no 3D modeling, everything was automatic. Now let's see how we can even further improve the visuals of our model scene. And there are two steps that we're going to take to do that. First, we upgrade the animation of standalone objects, like, for example, forklifts. And to do that, we open the forklift file in Omniverse. Here, the forklift position you can see is rotated, since AnyLogic applies different transformation to the file. So let's, for example, replace this auto-generated AGV with one provided from NVIDIA store. So what we do is add the new AGV model from NVIDIA store. We adjust its position, we adjust its rotation, we adjust its scale or its size. You can see on the video, adjusting its parameters. Then we adjust it to match the old model. Then we simply remove the old AGV model. So now for transporters or for AGVs, the new updated model will be used since we made changes to the forklift file. You can see we remove the old model from the tree view. And that's all we need to do to change transporters. Save the changes. Okay, the second step that we're going to take is improve the statics of the scene. So we replace textures, add new textures, we add asphalt, we add grass, we add blue glass on walls. We replace auto-generated trees with much more detailed ones. We also improve rack storages. Yeah, let's. Adding all the textures. I think what we also do is improve rack storages, and I think we also add boxes here. I replace old trees with new ones so that they match. I think the process is a little bit sped up here, but you can see what needs to be done. And everything is happening everything is yet happening in Omniverse. So we haven't yet been to the part where we want to do changes in AnyLogic. So yeah, this is the new look for our scene, which not yet finished, I guess.
Increase frame rate.
That should be faster, right?
Yeah.
Okay. Oh, what can we do? Okay. Yeah, the video is not as fast as it's supposed to be, but okay. So maybe we can just, no? Oh yeah. Okay, we were here, I guess. Comparing the animations yet again. From after improving the scene, we see the improved boxes. Pretty much detailed boxes with stamps and logos you can see on them. Even the duct tape on top of the box. And yeah, remember we changed the forklift file. And you can see the new 3D model for the forklift is used right now. So yeah, we pause the model here, and yeah, as a little Easter egg, to showcase the level of detail on Omniverse 3D models, we can even zoom in on the side of a transporter and see the warning sign. I don't think it's even fully loaded yet. We can even probably, let's wait for a second. Yeah. Okay, now it's loaded. We can see even read the sign, yeah, on the transporter. Okay. This is a new forklift. Okay, and this next a little more advanced section, let's see how we can control the Omniverse object animation from AnyLogic model. So let's take our boxes, for example, as promised. And we will use what is called the variant set, which will allow us to control the look of the boxes and add variety to boxes on the rec storages. So a variant set is basically a list of options or variants for object animation. Each option corresponds to a certain set of parameters which define the object animation. And here we'll create 4 such options for a box. So the parameter that is changed between variants here is the asset or 3D model itself. But actually, the parameters that are changed between variants can represent almost any property of the object, like its size, its color, its position, its asset, or even custom parameters. So here we add 4 assets into the file, into the box file. You can say 4 3D models into the box file. We adjust its positions, rotation, and size again.
Again, it's slow.
Yeah, the video is slower than it's supposed to be, but yeah, that's. Okay, like I said, we add 4 3D models to the file. We adjust rotation and size. I think I can. Oh yeah, it's down here. So next we create a variant set. We give it a name, palette type. And next we create 4 variants or 4 options for this set. From palette 0 to palette 3. And for each variant, we say one of the asset is visible, that is inherited, and other 3 assets are invisible. So in fact, the file itself actually contains all 4 of the 3D models for boxes, but only one will be shown depending on the currently selected variant of a certain box. And the currently selected variant of the certain box will be in fact controlled by the data sent from AnyLogic to Omniverse. You save the changes, and for visibility purposes, we can show the variant column here in the tree view, where we can switch between variants and see the result that each variant has a different 3D model used. Okay, next in AnyLogic, let's define the Omniverse properties of our boxes. That is our palette agent. So let's create a function that accepts type ID and returns a variant name according to that type ID. So since our variants were called palette underscore plus number, we create a function this way. And in the date string. And in Omniverse section, we select Omniverse section, create new prim to bind that agent to the object in Omniverse and specify the path to the ESD file that we just edited, the box file with the 4 boxes of 4 variants. Now to apply variants to this agent, we specify a variant set name, palette type, and pass the value of our function as the name of the specific variant. That's it. Of course, tick the box is variant, and that's it. Now, let's run the model again. And you can see on our rec storages, we see that the boxes on rec storages now have different looks. So in fact, the look of the box, the animation of the box, depends on the variant set name that Omniverse received from AnyLogic model. These models, again, are pretty detailed. You see the logos and stamps. You can see the crates with handles on them, duct tape on boxes. And this will conclude a little demo in which we showed new feature in AnyLogic that will allow the model to connect to NVIDIA Omniverse to improve the 3D picture of a running model. And we expect this feature to be released by the end of this year. And since this feature is not yet released, what you have seen today here is not a final product, not a final version, and of course, it's subject to change. Okay, and now I would like to turn it over to our alpha user, Ben Schumann, who already had a chance to test this new feature, of course, and on real client models. Here you go, Ben. Thank you.
Thanks. Maybe it's better that I stream the video, Dimitri, just because of your internet problem. So I'm going to stream that myself. I already introduced that I'm going to share 2 case studies. The first one is from a real client that I had recently, and they said it's okay to share this. And the purpose of this first video is first to show you again all the cool stuff. It's good to see that stuff again. It was really fast-paced, how you actually do that, but also how easy it is to do that for normal models. And then at the end of the video, there's going to be a little one more thing. So let me share my screen. And let's make sure I share the video audio as well. Do you guys remember how to do that? How did I share my video audio?
You have a checkbox, share sound on the share screen before you start sharing. When you click share.
I didn't have that. That's why I was confused. There was no checkbox for me. Maybe you guys do it after all.
Yeah.
If you do the manufacturing video first, manufacturing client. Okay, so let's have a look at a real model with a real client. This is literally my last previous client that I had. And we are in the world of manufacturing. So this client needed a virtual representation of their operations, of their manufacturing. They wanted to play with different employee shifts and assigning materials to different machines at different intervals, maybe even optimize it and look at warehouse utilization. So classical kind of questions, very typical questions that you typically see. So with AnyLogic, you often get kind of 3D animation for free, which is almost for free, which is fantastic. But wouldn't it be nice by using this model to also go to your manager and convince her to invest a little bit into maybe a warehouse extension? Because in our model, the warehouse is kind of full. If you look at it, wouldn't it be nice to have more space? And convincing with numbers is important, is very important, most managers would say. But if you're honest, there are other ways that you can help convince people. And one of them is visuals. Simple as that, it's a fact of life. So how do you create those visuals? It is really, really simple. In your model, in this model, basically what we had is that the actual layout with a 3D window sits in a specific agent type called plant layout. And all you have to do is click model and then render model in this new AnyLogic version. And instead of selecting main, which does not have a 3D window, so it's not even popping up here, you select the plant layout. And then you specify where should this be moved to, where should this static scene, the walls, the roads, the images even, where should they be exported to? And I'm exporting it to a file called model.usd. So in Omniverse then I can open this file and go to this project and find that model.usd. Just double click on it and open it, and we will see that static file. Oh, it lost the camera there, but here it is. We recognize this now. These are the walls, the images, even some static AnyLogic 3D models have been exported, like these warehouse racks. And even the path layout is exported as a visual construct. Now, given that Omniverse, and especially the USD file format, is becoming a de facto industry standard in many industries. It becomes important to be able to actually talk to people like that. So if somebody is planning a warehouse, there's a good chance they are rendering it already in 3D. So if you can then easily import it to your scene and plug it next to your warehouse, that's pretty powerful. But obviously just rendering the static scene is nice, but there's not a lot of value for us dynamic people who build simulation models. But the next step is quite simple as well. You need to drag in this Omniverse block from that AnyLogic version and basically tell it, hey, when you run the model, please link or send the live updates of where my agents are and what they are doing. Please send this to this model USD file as well. And please use the 3D objects that my agents are using. So whatever I see in 3D in AnyLogic for forklifts and people and stuff, please just use those. That's for now good enough. And if we start the model, it will link up to an Omniverse live session. The model starts. Let's fast forward a little bit to something when something's actually happening. So now we have things moving around, and the model already sends this into the void. And all we have to do in Omniverse now is to say, hey, pick up this void, join the session that AnyLogic has created a couple of minutes ago, join that and show me what's going on animated in 3D. So here we are, things are moving around. Not only are things moving around, little people and our forklifts are moving around as well. But you may also see that now we have the scene populated with these machines as well. There are a couple of machines here, a couple of machines over here. We have these little containers. Those weren't there before in the static scene. And the reason for that is that I did not export them in the static scene. My model architecture in AnyLogic does not actually have those machines animated in the layout. Each machine is animated by itself, as is good model architecture way of doing things. And this works absolutely fine in the Omniverse. These machines are now live agents as well. And kind of AnyLogic says live, hey, there's a machine here, please animate that. Now, what else do you notice? You see these little people moving about, but they're kind of moving about like this. That's on purpose. Let's have a look at that. AnyLogic 3D people are kind of optimized for performance, so they don't look very well upfront, but it's okay. I mean, this engine is optimized for being rendered on CPUs, not GPUs, so that's totally fine. But in Omniverse, things are a different beast. In Omniverse, everything's optimized to be rendered on graphical processing units, GPUs, graphic cards. So our people can look a lot more realistic and a lot nicer, and it's very easy to replace your AnyLogic humans with custom humans. So all I did was basically tell Omniverse, replace the AnyLogic 3D animation with a specific USD file. Now, this specific USD file I just pulled from an online free repository of thousands of USD files. It's a guy walking. And this USD file is, super detailed, lots of stuff going on there. It even has animation. So you could even make him walk, although I haven't been able to make this work yet. Still in contact with NVIDIA on this. I think it has to do with a live session thing. But it may be possible. I can't say it's not possible or not. I'm still working on that. We'll see. Oh, and this guy actually has textures as well. So that's all there. All right, so back to our use case. You want to convince somebody to invest a ton of money into some infrastructure. You've shown them the 3D animation now. You've shown the 3D animation in Omniverse, nice rendering, things are moving about. That's all really cool. But there's one last thing, one more thing up your sleeve that you can easily do with the Omniverse now, and that is to start playing with these kind of beasts. Let's have a look at that. So if you have a VR headset, you can actually very easily visit your AnyLogic model in VR live. It's quite simple to do. All you have to do is literally go to Windows, Rendering, and activate the VR. This brings up this little window down here. If you have your VR headset linked to the machine, So VR is now activated. It's literally this headset looking around. Let me slip into this world and see what we can do. All right, so here we are. We are world. I can walk around and bird's eye view my factory or go in there and go up very close with these avatars if I wanted to. And I can walk around my facility, no problem at all. Now this is also live, so these people are actually walking around and the facility is actually working. So I can observe exactly what's going on. I can go into my warehouse, into my storage and check out things live. And if I want to invest into a new warehouse, I could just walk over there and demo it to whoever needs the demo. So this obviously opens up a whole new world to your AnyLogic modeling. It's quite exhilarating to go into your own model the very first time and walk around it and see what you actually built. But there is also value behind it. It's not just toys and nice visuals. As we know, decisions are made rationally, but not entirely rationally. And if you can actually walk through a facility, that has advantages. But also, the more advanced your simulation models get and the more we move forward as a simulation community, the more other parts of decision making come into play. So when it comes to building a new warehouse, there will be teams that are working on it being, user friendly. Does it actually work out? Or for factories, do the robots have enough space? There are all sorts of industries working on that. And if you can link up with them and connect your strategic support model with their live operational model, that's quite useful. The other thing is now it's like the web front end that you can have for your AnyLogic models, where you embed your model into a web page. You now have an open universe ahead of you. You can make your models look as sophisticated and cool as you like. You can combine them with other Omniverse tools. There's lots of stuff out there. You can do the VR thing. You can link up with other teams who are using USD. It is becoming quite the industrial standard data format. Or if you want to turn your simulation model into a Pixar movie, because USD has been invented by Pixar, there we are. Thanks a lot. All right. Oh man, I'm still so addicted to this stuff. This is so much fun. Building your AnyLogic model and then actually walking through it in VR is fantastic. We have a second video with a second client, Goldward Research Labs, who are also presenting at this company at this conference. And the purpose of the second video is to go into a little more depth with a more complex model. This model has basically two models combined with each other with fairly complex hierarchy and stuff. And even then, it is possible to create a VR scene and an Omniverse connector. So Jakob and Voslo helped me prepare the model for that. So let's have a look. And at the end, I'm also talking a little bit about performance and computational requirements. So Dimitri, if you could play the second video as well, that'll be great. Thanks. All right, let's talk about a bigger model that has a much more complex architecture. Is that possible to easily animate and show in the Omniverse as well? Let's look at the inventory digital twin developed by Goldward Research Labs. As we'll see in a bit, this is quite a complex model. There's actually several models, a lot of hierarchy, a lot of technical stuff under the hood, developed well before Omniverse was even a thing or started development. So is that ready to be used in Omniverse? Let's first look at the model. This is quite a useful thing. It started out as an educational tool to teach you about replenishment policies, but these days it's actually a true digital twin that you can use for your live supply chains and warehouses, feed it with real data and see how it performs. And the core of the tool is basically the comparison ability of using different replenishment policies like min-max, the latest DDMRP, TOC, theory of constraints. Lots of charts, lots of insight, lots of cool things. But if you're an attention-filled CEO, the one thing that you really like is the little 3D button. So let's have a look what that looks like. So in 3D, this is a very simple representation of very simple test data, but you can visualize your supply chains. You have a couple of deliverers that produce raw materials for you, and you send out different orders and different sizes and different intervals to those factories, and they deliver their raw materials again in different quantities and different time intervals. And in your warehouse, you can see how that impacts your storage capacity. So that, for some decision makers, might be a lot more easy to understand. Now, how does that look like in Omniverse, you think? Let's have a look. So there we are. This is a simple export. Nothing has really changed. I literally just click play and everything is automated. So you can see the standard AnyLogic animations for the trucks. It's nicely rendered. You can do and already do cool things with this. And even in a live session, you can now make this look better. This is always just the starting point. So in NVIDIA Omniverse, in this USD composer, while the model is running, even then we can improve this model. Let's say you're kind of, you don't like these simplified trees. Well, you can just delete them live and use the NVIDIA store to drag in a different tree. Just make sure that the scale is okay. And you have a nice tree now instead of that simplified one. And this is Omniverse. This is very, very powerful graphics. If you zoom into this thing, you will see it's down to individual leaves. And this would obviously be impossible in the 3D engine in AnyLogic, but in Omniverse it's all about rendering efficiently. And if you invest a little bit of time, you can make this look extremely realistic if you like. Now again, where's the value in that? Well, value comes from those decision makers. So if a decision maker can actually visit the warehouse that he's supposed to invest 50 million in, that's a bonus. That's useful. But if he can visit it, in person, that's a whole other story. Let's have a look at that. All right, so here we are. We are in our shop, and very easily we can now walk through our shop and see what's going on and visit all the details in this shop. This is still default AnyLogic scene rendering. So a lot of stuff that has been rendered here for you. Very dark room here, but you can test out all these things. And if you would build up your warehouse, you could walk through the aisles and see how things are going, or you take the bird's eye view and watch the whole supply chain and animate that, no problem. Now let's explore some technical things here. This model, as I said, is a bit more advanced because it's actually two models. There's a base model that has the logic of everything, and then there is the kind of front-end model that holds all the hand-holding and animating stuff for users. So on main of the animation model, there is no 3D. There is no 3D window, and there is no definition of, of that world. It actually sits deeper in the hierarchy in a specific agent type. In this case, we put it into animation 3D. So this is where the 3D model sits and where that animation sits. This could also be data-driven, but if I want to render this statically into the Omniverse, it wouldn't easily be possible, but we are in AnyLogic. Everything is always possible. So let me show you how you could do this. You can simply create a new model and just copy over your animation into there. Just take all this stuff and copy it into your new model just on main, drag in a little 3D animation. And very last thing, just make sure that your scale, the scale object, actually matches the scale from your original model. And now with this, you can easily render this into the Omniverse. So this will actually render the static scene into Omniverse. If I click render model, I'm saying, please render whatever you see here, all this static stuff, render it into a model.usd file. And this is what we see in Omniverse then. So this is the static scene just rendered from AnyLogic. It sits in this model.usd file down here. This is where all the data is in there, and I can look at it. And everything else, all the dynamic stuff, what do the cars look like, is then put into separate USD files. And when I have exported this once, when I've rendered it once, I don't need this model anymore. I don't need the static scene anymore. From now on, when I run my normal model, it will connect to that static USD file. So running the model, it now sends continuous updates to that USD scene. And the way it does that is via this Omniverse connector object. So in my animation 3D, I'm saying, please send this all to this model USD file, the same one where I put the static scene in previously. So everything is sent here. If I now connect to this live session, it will pick up the live data, and we see our animation. Very quick and easy. So a couple of notes from my experience the last couple of weeks and months of testing this. It's once you understand Omniverse, once you understand USD file format and the kind of philosophy behind it, it's very easy to get this stuff done. It's a couple of clicks. And from then on, it's up to you. What do you make of this? How realistic do you want this to be? It's similar to how AnyLogic allows you to have a web front end and run models on your web front end. But what you do with that web front end is your decision. You can build the most elaborate web page or just a single button. It's up to you and up to your use case. So the flexibility is great. What you do need, though, is not a weak machine. Just running Omniverse and connecting to AnyLogic and rendering it, typically not too heavy. You do need a graphics card, for Omniverse to even work, but it doesn't have to be a super beefy one unless you start dragging in a lot of trees and stuff. What you do need a beefy graphic cards for is if you want to go down that route. These VR headsets eat graphics power like crazy. I've got an RTX 4090, which is the best that you can get, and with that, no problem at all. With a Pimax Crystal headset that I have, it looks 100% realistic. You don't see pixels anymore, anything like that. So it's super, super powerful and very, very cool, but you do need the power. All right, thanks a lot. All right, I'll leave it to Dimitri and Roman to take on the rest and take the questions. But this was really, really fun. Thanks for taking me along the ride and letting me play with it. You guys are still muted.
So yeah, thank you, Ben, and we'll gladly answer any questions that you might have about Omniverse connection. I think most of the questions, as we read the chat, most of the questions were answered. Some of them weren't, so we try to cover them.
Yeah, thank you, Mikhail, to answer most of the questions. So let's see the not answered ones. Does Omniverse model work also with the GIS map? How you use it for it? Not out of the box, but you can, I believe you can bind it via code. You can send attributes and variants dynamically to Omniverse, so you can do almost anything. It depends on what you need. Next one.
So answer.
Can we dynamically change colors on objects and size? Yes, you can, as well as other attributes. You see it with variants, but you can also dynamically pass the data to all kinds of attributes of objects. Does the new feature need Omniverse license? No.
So maybe just to expand on that, Omniverse is basically open source. Well, it's not open source, but it's free to use. I'm not sure. Professional users may need a license. I'm not entirely sure, Dimitri. Did you look into this?
If you do not use it as a service provider, you don't need a license. So if you use it internally in your organization, you don't need license. But if you want to use NVIDIA Cloud, you need to pay to NVIDIA. All changes at Omniverse side will not affect AnyLogic model. Yes, so we don't support changes from the Omniverse to the AnyLogic model. I believe that's it.
Yeah, I guess.
Can I create a custom 3D model from scratch in Omniverse and bind it to an agent? And yes, you can. You don't need to render it from AnyLogic model. You can just bind your existing 3D scene to AnyLogic model via Omniverse connector element, and that's all. And if you want to do advanced binding for different agents, you need to bind all of the agents to your objects on the scene. About T-pose, I believe it's possible to get animation works in live scene, but you will get not very good performance, but still it's possible. And yes, you can stream information to change variant to the object on the scene. So one variant will be moving human, for example, and the other variant will be still standing human. So it will be more realistic, more relevant to the model.
It should be possible. From what I figured out, I wasn't able to get it properly working, as you saw. But there are basically two ways of animating. There's the way that Dimitri and Roman has shown with the, you have one box object, but it's actually 4 different states. And from AnyLogic, you can tell now use this state, now use that state. So you could easily have this version of a person and then, I don't know, this version of a person. But there's a different way of animation in Omniverse, which is real animation. These are skeletal things, and they can move fluidly in time. And what I was trying to do is basically say, as soon as an agent moves, use that fluid animation to walk. And that's what I didn't get to work, but it should be possible to work. So we'll look into it. I want this to work as well. I want us to look like a pedestrian simulation with people walking. That'll be really cool.
Okay, how long does it typically take to render a model? It depends on GPU you have. So for our distribution center example, it's minutes, several minutes.
For the models that I was showing, it was also less than a minute, but I've got a beefy graphic card. So, but it's not in the orders of hours. It does take some time, but you only do it once. So you know, it's okay if it takes a little bit of time.
Yeah, and we use a laptop, so it's not very good for rendering.
Now, one person was asking about the minimum required GPU power. So the minimum is you need to have an RTX card, an NVIDIA RTX card, and it has to be an NVIDIA card. There are other graphics cards which just don't work. So an NVIDIA card, but an RTX, the cheapest ones are 3 or 4 years old, and cost 200 or 300 euros on the secondhand market these days, like an RTX 3060, 3050. And they're probably okay for the simple kind of stuff that we've shown here, not in 4K and not in VR. But yeah, you get cheap cards and can still play with this. Oh, there's one more question, guys. Why was the NVIDIA Omniverse your choice? That'll be interesting.
Yeah, because it have no license limitation to use. You don't need to pay to NVIDIA to use it in your organization. Second, it use OpenUSD standard, open and popular standard. So that's two main reasons.
This USD file format, as far as I understand it, is turning into the de facto standard of 3D animation these days. And one of the big advantages of that file format, it's open source, so it doesn't belong to NVIDIA. It was, as I said, invented by Pixar to render their movies. But one of the advantages is that you can have easy live collaboration. So you can have several people working on the same 3D model at the same time. You can have other people running AnyLogic simulations in that. So it's quite flexible. Did you guys look into Unity and Unreal Engine?
Yeah, but I
did at some point, definitely. I was researching it. Yeah.
But still, we decided to stay with NVIDIA and OpenUSD.
Yeah.
I think it's the right choice, to be honest. Unity is basically just for gaming and mostly mobile gaming, so it's really not the use case. NVIDIA is a power horse, and they are heavily investing into this. You know, this is not going to go away anytime soon. So I think it's a good decision. Unreal Engine is also mainly for gaming.
And we can read USD files into AnyLogic, so we only need one 3D object. Yeah, for now it's not possible to use USD in AnyLogic, but we considering this to do in future versions. What about conflicts from multiple user changes in your scene? You don't have direct conflicts. You just need to discuss before what changes you need to do. So you need one of you change the model, and the other change the scene appropriately. So you need to discuss this collaboration before, and so, but no direct conflicts.
This is the whole kind of spiel of USD, is that it avoids conflicts by design. You all work on one server together, and when you change something and somebody else changes something, you both send commands to the server essentially, and they're not going to arrive at the same time. So there won't be conflicts, and everything is tracked in history. So from my experience, no expert at all, but it works quite elegantly. And the whole point is to avoid not have conflicts anymore. This is not like Git file versioning.
Yeah, we are talking about changing scene simultaneously, but I believe that was about changing the model and Omniverse scene.
Yeah, as Dimo said, no direct conflicts, but your animation, of course, might look not what you like. You might not get what you expected because someone changed the model, and now different updates are sent to the Omniverse. Of course, you need to collaborate with each other to expected animation, of course.
So I believe that's it. So
there was one question, I think we skipped. One person was asking, like testing this as a beta tester. Is that possible? Is that something?
Yeah, Anastasia already answered that you can contact support.
Do it. It's fun.
Okay, so thank you all for watching.
Yeah, we hope all of you liked that presentation. Found it exciting, at least. And Ben's videos are also, yeah, quite the breakthrough, I would say.
Well, thanks for having me. You guys did a really, really good job. This is fantastic. This is really, as you can see, there's so many things floating around now. People are really excited. This is really, really cool. Thanks a lot, gentlemen.